What's going on, folks? Welcome to the High Performance HVAC podcast, where every system has a story and the numbers never lie. We're here to measure, test, and expose what others overlooked. I am your host, Casey Contreras, and we got a really cool guest for you. Known this guy for a long time. Actually, the first time I ever met him was in probably one of my first combustion classes I ever taught. Vince, welcome, man. Thank you for taking the time and hanging out with us for a little bit.
Thank you. We're out of the Vince Lopez. I own Comfort Solution Technologies. I'm the owner, and small mom and pop company out of the western suburbs of Chicago.
Very cool. What's give me give me a little background about you, man. How did you start in the industry? How did you end up where you're at? And just kind of run with it a little bit.
Sure. So I graduated in 1999 from high school. I already from a trades class. I already had a recruiter out. I believe my sophomore or junior year for electronics class, and they were trying to recruit just some talent from the local high school that might want to go to the trade school, Universal Technical Institute out of Glendale Heights, Illinois. And the recruiter stopped at our high school a couple times throughout the year and told us just what the potential of that career and could bring you. And I've already determined at that age already that I like working with my hands. I love figuring things out, but I didn't necessarily want to be in an office. So that's kind of what got the ball rolling for tech school. And I graduated tech school in about a year. It was a 10-month course, 5 days a week, 8 hours a day. Pretty tough course. Um, Really great instructors. They were a little tough on you sometimes, but really great instructors. And glad I went to the tech school part because that kind of gave me um, just understanding on service side of things. The tech school was heavy on service and that just learning some of the foundational stuff from bookwork, mathematics, this equations, but putting it to work, in the lab, and that kind of got the ball rolling for me to get in the field. So I technically got in the field of August of 2000. So I've been in the industry pretty much service related the whole way since 2000, August of 2000. And just definitely one of the things that got me interested initially was how much movement there you could have in the industry between just different segments within itself, HVAC, how much it entails. So um, um, let's see here. I guess for a couple of the companies, once I got my feet wet, I was mentored. I back up. I was mentored my first few years going into the industry, and then after I got my feet underneath me, I start helping a company, western suburbs of Chicago, run their service division, and kind of was on my shoulders to kind of figure out problems.
Yeah.
So that gave me a lot of grit and built some character because uh, not every day was fun. A lot of days were, but not every day was fun. Um, but yeah, definitely built some character, and I knew how much work I'd put in myself into the industry. So I just figured, how far can we take this for myself personally? I want to see how good I can get. Um, After about 11 years, I kind of hit a wall. Um, just seemed like knew myself I need to get better and improve myself and work on myself in my career, but just seemed like the owner wasn't interested in us learning so much and
Hmm.
didn't want to reinvest into the employees. And so I started questioning. like I just knew I didn't have that drive I used to. Um, and I knew I had to get like do better, but I didn't know where to go, like what to do. Um, so from there, I started working for a company closer toward Chicago, and um, started working with an engineer and started thinking differently because it just seems like when you're a technician like myself, service technician mainly, a service manager, I know there's sometimes a discrepancy of what we see in the field versus what they want.
Mm-hmm.
And so I started working with the engineer a little bit, see what they wanted, understanding their terminology a little bit more, understanding what I see in the field and how we can make this work better, or how do we fix this. At the end of the day, um, no one's trying to shoot themselves in the foot. You're just trying to come up with an answer and put your brains together with an answer. Trying to get an answer, especially for just so you can get the without some of these answers, and especially commercial, getting occupancy. There was no check being cut. The final checks.
Yep. Got to get that occupancy tag.
Yeah. So along that front, I just started thinking a little bit differently. And if I didn't meet the gentleman that mentored me, his name's Paul Christos, um, just his insight into mentoring me. If I had any questions, he would answer them, and that got me more involved in just running down rabbit holes, I guess, so to speak. Met my first air balancer at a commercial job site when I was working with them, and he was checking our work. The ductwork was done, rooftop units were in. I remember the job; it was for a PetSmart at Matheson, Illinois. About 26 RTUs installed. I was there to commission them, making sure the wiring was correct, doing startups. After that was done, an air balancer came to check our work with the airflow hood. And I'm like, what the heck is this? I'm like, this. And he was in a nice polo shirt. Uh, um, he see me walking around. He spent a few minutes talking with me. He told me he used to do what I did, and now he's moved up to doing some air balancing work. And so I was just very intrigued that he was that certified or competent at least enough to where they're validating the airflows coming out this system as the engineers designed. So we weren't qualified to do that. That's why they were, testing that out for us. But was just very intrigued by that. So yeah, that started me just thinking a little bit different on the commercial side of things. And the company was starting to send me out on the calls that the company would just get stuck on. Even other HVAC contractors, commercial contractors, they would call the company and look for me to help figure out the issue. What got me into NCI was I love having answers for clients and people figuring things out. I know I don't have all the answers, but I like to figure out why. There was problems in the commercial sector. We seen it first, then it trickled down to the residential sector, where the system mechanically is working. We cannot figure out why it wasn't cooling enough, heating enough, tripping limits. Just looking at it more like a system design, there was just where a lot of them they were working, but we couldn't even tell you how well the AC was working. We couldn't dyno it or anything out in the field. So we were at our wits' end with a lot of them, with some of them, I guess, where they're mechanically running. But if you took the deeper dive and using NCIs, like you're looking into airflow, you're looking into BTUs, calculations out in the field, looking at static pressure, a big thing. We started with static pressure. That opened our eyes to a whole new level of diagnostics. And my technical prowess is just more mechanical, but this opened the door to something that was just felt like um, you could have an answer almost for anything.
Oh yeah.
And that was like 3 years in only. We were starting to get answers for stuff.
So you
So
became an airhead first.
yes, that's where it started with Airhead.
And
Yep.
for everyone watching, airhead in this industry is a awesome term. So that there ain't no problem there. So you are proud to be an airhead. How did you? So you started off on the air side and saw how much that opened up. How did you get involved on the carbon monoxide and the combustion side?
Yeah, actually, yep. Thanks. A good question on that. So, um, I was actually let's see here. Was exposed to the NCI, yep, airflow class, air balancing class, um, in April of 2014. Um, I was with that company till about 2017. Went out to Colorado to kind of fall of 2017 just to see how much I could learn from what they do out there, their hydronics, and just what do they know? What can I learn from them, and what can I bring to that table for them?
Yeah.
Um, I was exposed out there to combustion analysis that I never knew the safety level, and just I had heard of combustion analysis, but no one really ever did any testing.
Yeah.
And out in Colorado, they take it a little more seriously. It looks like, um, and during just standard maintenance, it was always protocol for them to do combustion analysis on their
Hmm.
equipment. Um, and they didn't go through NCI, but they had some. They had, I think, one of the service managers did go through an NCI class, and then it's kind of let it trickle down from there. Um, One of my first maintenance of that stint over there um, was a less than a year old furnace. Actually, the furnace was only 6 months old. We're doing maintenance. An older gentleman was I was kind of following his lead. He was showing me, just making sure the ropes, make sure I was doing my maintenance correctly. We were pretty much packing up our tools for today, and he said, "There's one last thing we have to do before we leave. We have to do combustion analysis." So we packed up, figured this is a new furnace. It's going to be golden, like it's going to be we're out the door. Um, Put his combustion analyzer on there. I still remember to this day, 2,500 parts per million, and climbing.
Wow.
It was spiking his meter. He pulled his combustion analyzer probe out. It was still climbing. Um, it was a newer furnace, 6 months old.
Yep.
And I could not believe how deadly that was. And um, after looking up the data plate, this and that, and all that stuff, found out the furnace was incorrectly installed. Was not the right position. I believe it was downflow. Let's see, downflow furnace installed horizontally, something like that. They thought it
Uh-huh.
was just upflow. Yep. And we told the building owner. They were very happy that we found the issue, but we told him to find the company that installed it so you can get your. And he had to pay us for a whole new furnace, but
Yep.
better than someone possibly being injured. That was my first stint into combustion testing, and that blew my mind how a new system could be running that deadly.
It's that's actually kind of that's really cool. Just the fact that on your first combustion analysis, didn't even know you were going to be doing it, you run into something that deadly. Um, and of course, there's numbers thrown around the internet where things are supposed to be at, and just for the guys watching this, I mean, 2,500 is way up there, and the fact that it was rising, it shows a lot more issues than just the actual level of CO. Um, so that you just visually seeing that, you knew you were missing a piece of the puzzle.
Oh yes, yes, yeah. Um, so that's how it got me started into trying to understand it a little bit more.
Hmm.
Actually, a lot more. um, and I think I was talking to Mike Pay at that time. So
Yeah.
um, I was on the fence of starting my thinking of, okay, I got to run with this combustion analysis thing. I was going to take a class in Utah, paid up my own pocket. Um, the company didn't want to send me to an NCI class that was out in Utah,
Yeah.
so I wasn't happy about that. They just wanted you to just learn from hearsay, this or that. At least they found that problem, so I definitely learned something. But I wanted to, like, how do we, just do this a better way? I want to take it more seriously. What do we know are the good readings to get to? What's a good oxygen rate and how's it firing? Um, so that's when I initially then was talking with Mike Pay from NCI, and was starting to get the ball rolling. I was on the fence. That's when I decided to start my own company shortly
Yeah.
after.
Yeah.
Because if they weren't taking it seriously, like, they could take it a little more seriously. I'm glad they showed me that. But it just, how am I was going to take my own vacation days to go to this class, my own money, which I had no problem. And they still basically didn't want to let me take off of work to go to this class in Utah. And that's a real story. I'm not lying.
Yeah.
And so that told me that they're maybe limiting your knowledge a little bit.
Yeah.
The service manager maybe was, you know, and so I figured if I'm going to go with this, and that's when I started. About 4 months later, started my company, and I didn't take any clients in for a while. That's when I started getting these certifications behind me for my own company. Started getting
Oh
them from
yeah,
other
I see him.
companies. Yep, I started with believe it was air. Let's see, which one was it? I think it was air balancing, HVAC system optimization. Roughly, sorry, not system optimization, but HVAC um, system specialist. Then there was the in Des Moines, Iowa, was my first class of 2019. August of 2019 is when I went to a class in Des Moines, Iowa for CO and combustion. That blew my mind. Out of any class, that one blew my mind. I'm like, how do we not know this stuff? I was like trying my best, 20 something years, 18 years in the field, leaving someone's system maybe not safe, not knowing.
Yeah, it
And
is terrifying. I remember I was an airhead first, and I'm like, oh man, all the customers I'm going to help, all the comfort levels, and I know
yeah,
all of this stuff now.
right.
Great. And then, same thing. My boss was like, no, it's California. We don't worry about gas heating in California. No big
Oh,
deal.
wow.
And then I
Yeah.
finally
Yeah.
get to a combustion class, and I'm like, oh my God, shut the company down now.
Yep.
Terrifying.
Right.
Now,
I felt
with,
like I was clobbered upside the head with the info they gave you at the beginning. Like, oh my goodness. Sorry.
yeah.
I felt like I was clobbered with information. Good way. Sorry.
Now,
Sorry.
with all of that, you've got your first experience. It's a horror story, and then a couple years later, just recently, you run into a similar situation, but you weren't out doing a maintenance with a contractor. You weren't doing it for your own company. Um, there's the story that you have is absolutely terrifying, and it's a little different approach, or happened a little differently than
Yeah.
typical service calls. Um, you know,
Sure.
let's talk about it. Let's hear what happened there. How did the call even come to you?
Yeah. So this is how. Yeah. Yeah. Definitely not the most. Just typical way you would think that you'd get an issue with combustion, especially when you're not there when that this call comes in. Um, so how this came about was originally when I um, moved into this home that I'm in now. Purchased this home. Um, Obviously, I went through the HVAC system. First thing I did when we bought the home was I tested the furnace first.
Mhm.
Tested that as soon as I came in, make sure combustion test was performed. Um, so we started doing some energy auditing, load reduction on the house. We did um, air sealing for the attic. So they took all the insulation out, the old insulation out, put some more insulation in. They air sealed the cracks. But even before they got to that, the company that did the air sealing, they were known for using blower door tests to prove that to prove their work. What is it?
Mhm.
Reducing your load in your house. The other part with that too, I think, is a safety part. They test your appliances too for combustion. So this company that does before they do any insulating and air sealing, they will do a blower door test and combustion analysis on your appliances.
Interesting.
The gentleman that did the testing, that came out originally, that did the testing, as soon as he walked in, he noticed my office had NCI certificates hanging up on the wall behind me. As soon as he walked in, and he spoke to me about him because he's familiar with NCI too. He's a
Yeah.
BPI guy, and so he was saying, just commending me. I'm a little bit younger than him, so he was just commending me on, just with the company, just getting started off, with these certifications, but just trying to do things, on the up and up, and trying to be competent as possible for my industry. So that's how this call actually came about. Was um, so after he left and did his testing, he took my business card and said he would refer me to any clients that need any HVAC, work, or just not that he's looking for. This is more so. So when they do their testing, they can't touch the HVAC equipment. They don't know. That's not their thing.
Yeah.
They need to trust someone. If they're going to rely on somebody to fix the equipment, they're going off data, a lot of data. They have a lot of data to use to say how something's performing. They want to be, they want a competent company they can trust too, and that's how it all came about. And I think the NCI, seeing that NCI was where a lot of our certificates are from, they figured we have to be on the up and up.
Yeah.
And that's how we were just for the gentleman that does the building testing and the blower door test. He kept us on his kept me in his contacts, and he calls us now. So if someone has a comfort issue too, but the safety issue one is how it all came about here just about a month or two ago. He called. I was When he called a month or two ago. The gentleman for a home they were testing towards Kero Stream. They were doing a test in, so they were doing air sealing for this. Going to do air sealing for this client. Did the test in data, building pressure testing, all that good stuff. And when they test the furnace, this is test in. That's the furnace um, was the carbon monoxide level was at 1,839 parts per million
Holy moly.
on a test in.
And how do you know how long that or how old that unit was?
So this unit's let's see here. Let's see, I get a lot of documentation here. Let's see. This unit is from 2011, August of 2011 manufacturing date on it.
Hmm. And this is
Three.
before they did any air sealing or anything like that.
Yes. Yep. So they do this test here to make everything. I think so. If anything spills, I think NCI is obviously very big on that.
Yeah.
A lot of people can get sick from. They're worried about a cracked heat exchanger. Yes, that's a big thing to worry about. But
Mhm.
spillage, we've seen more issues with spillage than cracked heat exchangers,
Yes.
and I think they're aware of that. So they start tightening up the building home. Things
Yeah.
can change.
2011. So we're talking what, almost 15 years in operation, if I did my math right.
About that. Yep. Going on
All
that.
it took was one proper condition to hurt or potentially those customers to lose their life. And I mean, if you guys look at those numbers, 1839 of measured CO, 2494 CO air free, those numbers are over any standard out there that would require a disablement and red tag, right?
Yes. Yes. Yeah, that definitely would be a red flag would be at 400.
Yeah.
And
All
for
right.
typical
So
protocol, like our NCI protocol, we want to see it less than 100 to be safe, less than 100 parts per million.
absolutely. Yep. And stable. Now,
And stable, correct.
was this your test or was this their initial test and they sent you a picture?
This was a gentleman that this is the insulating company that does the blower door test. So they have their own combustion analyzer. This is their data that they're sending to me. Um, that's how competent they seem to be as an insulating company too, where they've invested into the instruments, the training. So this is what part of their thing they do before they do any insulating, which is really, I mean, that's a high standard that they go by. It seems like.
And then you've got, so after they did this, they didn't initially call you, right?
So after they did this here, yeah. So after they didn't initially call me, no. So that was from the notes here. The initial visit of 1,839 parts per million.
Mm-hmm.
That was at the initial visit was June 2nd. That's the initial visit. They went back out. So the company that does the insulating went back out. The gentleman that does the testing, the blower door test, and does the he has a combustion analyzer, so they test. So he's qualified to do the testing. Not everyone in the company is qualified to do the testing that he does.
Gotcha.
So that's why they send him out in particular. Um, so he had spoke with the homeowner and told her to call the contractor out and let them know that the furnace, is obviously very unsafe, and so they can see what the issue is and try to look into it more to definitely get something figured out to resolve it or replace the furnace, whatever they got to do, but to come back out there. She said the homeowner had already had them out some time before that, so they came back out again, the HVAC company, and let's see here. I'm not sure what work they really did on that, but so she had them out again. I'm not sure what adjustments they made or anything like that. Maybe I'm guessing they must have made some adjustment. I'll still come back to this, but I don't know what was really done. But what by the time the insulating company came back out again, maybe a week or so, right in there, came back out again. They tested again the appliance to make sure it was safe, and they found it even higher at 5,309 parts per million.
That is nuts. I mean, I could see
After
what they
calling them
did.
back out.
It's for everyone watching this, I got drilled, my first CO class because we've all been told gas pressure, right? I mean, Vince, Adam, I know we've all
Oh,
been
yeah.
told tune in to 3.5. Well, you're measuring pressure. You're not measuring, really the quantity of fuel, the type of fuel that you have. And I mean, I look at the before and after numbers here, and it looks like whoever was out there tried to tune that thing in to 3.5. But I'm assuming, but it's pretty common that most likely the manometer that he was using to tune that thing in was not accurate. I mean, would you agree?
That whatever they're using, that is definitely an adjustment had to been made. Yes, to
Yeah.
climb to 5,309, and obviously that was an even deadlier adjustment. Not obviously not intentional. You wouldn't think anyone's doing this intentionally, but that's the problem with this is when we're not using the right instruments. Is something that's not intentional, you can make something even deadlier, and
Yeah.
then you're dealing with the occupants and her kids and the family. So that was fortunately checked by the insulating company. So um, from there, the gentleman that was in charge of this testing, before they can move forward with any air sealing and load reduction on the place, um, he specifically told the homeowner that he wants to talk to the HVAC company, the tech
Mhm.
HVAC company, the HVAC company, and just because obviously for him, most homeowners don't understand our HVAC as much, as we do, obviously, or else
Yep.
um, that's something you know um, with being able to research nowadays, people are learning more. So and asking questions, AI and stuff like that. But so he talked to the HVAC contracting company, and this is the kicker on it. It was just um, he was told. Let's see, the tech that was there told this is an email sent from the insulating company. The tech that was there told me that they do not have one, which is combustion analyzer. Said that the company felt they were too expensive,
Hmm.
and they're a way bigger company than my company. I'm a mom and pop, and we have two already. I mean, think we're not that big company, but we have two. So they're used on every single maintenance, whether it's a service or the service call maintenance. It's anything with combustion. It's used every time.
Well, let's.
There's no excuse for it. Sorry.
No, you're fine. Just things bouncing in and out of my head. So the contractor states that they don't have a combustion analyzer because they're too stinking expensive. And you say they're a very large company. I look at that as the insulation company and you not only saved the customer's life, you just saved that contractor and that technician not only from lawsuits but potentially prison time as well. That
Ex-
is that's insane.
How
It's
can they? It's just, yeah. It's like how haphazard or negligent, and it just, it's just hard to comprehend. It doesn't make any
yeah,
sense why you would,
yeah,
risk it, and then risk it and your integrity of just just knowing something's dangerous. Yes, excuses he didn't know the readings, or
yeah,
but that's not an excuse to you didn't know or didn't have the instrument. I mean, what? Just
yeah.
it's
And that's how they're going to
dumbfounding.
look at it in a court of law, right? If that something happened to that customer, that tech, that company would have been pulled into a court of law. And if the judge or the lawyer or whoever it is asks them, why didn't you test combustion or why didn't you check for safety? And he sits there and says, well, combustion analyzers are so expensive. We don't have one. They're not going to be like, oh, okay, you're free to go. That is not an excuse. I mean, like you've learned through those classes before, we go over the Wanton Act and how we can't be negligent. It's our profession, it's our craft. We need to do these things, or otherwise the liability is huge on all of our shoulders.
And why be in business if you can't have the proper tools? I know that stuff costs money. We know that, right? But
Yeah.
you have to take it serious. We're not in 50 years ago. Jim Davis has had this stuff, the curriculum out for
Yeah.
decades.
Yep.
Invested what 40, 50 years of his life.
Yep.
So it's there, and there's so much access to information, which is nice nowadays with YouTube, all this other stuff. People are more aware, and
Mm-hmm.
just your homeowners are getting a little more aware. It's fine, but so there's no excuse now in this time frame to like have that attitude. I mean,
Yeah.
yeah, it's that's obviously incompetency,
Oh yeah.
and
40,
negligence.
40 years ago, combustion analyzers, several $1,000s, and of course, with how much, that kind of money at that time was just insane. But nowadays, with all the different instruments that we have available, all the competition that go. I mean, this stuff is not expensive. Some combustion analyzers you can get for cheaper than a set of refrigerant gauges.
Yeah, dude, you're not kidding. You're true. Yeah,
Yeah.
you're right on that. Yeah, yeah.
So you go. So we have negligence on the contractor. That's, it happens. So you finally get to the house. How do you walk into the house with confidence? You know you're going to be able to find something. You know you're going to be able to fix the situation. Tell me how that kind of rolls out.
Yes. So this email here, yeah. So the email here was sent out to me from the gentleman doing the testing, building the blower door test, the testing the appliances. Sent me an email with screenshots of the combustion analyzer. So very detailed. Is BPI certified, so he's probably into the data like us airheads are at NCI.
Yeah.
So very detailed. He first called, and we were in the middle of 95-degree weather. So when he called, he left me a voicemail. Very long voicemail. Very worried. You can tell in the tone. Very worried. I got back to him as soon as I could, probably within the hour. He got me this detailed email out and had the screenshots of the analyzer, the Tesla analyzer combustion readings. When I seen the screenshots of the combustion, just that alone, just knowing, and if it wasn't for NCI, I would not know what to do with these numbers. I wouldn't know how to place them. Probably would have taken a decade to figure out that stuff, Jim Davis, just the basics 101.
Yeah.
But thankfully, with NCI's classes, I mean, literally, it's just like from my first class, because we get recertified every 2 years on our certifications. Just anyone at one of those first classes of NCI, just for combustion, seeing the screenshot, the two screenshots, what stuck out to me was the O2, the oxygen, is what stuck out. I was very confident that when I seen that, like, okay, if the furnace is not safe, we'll definitely better let them know, if it's a heat exchanger issue, this or that. But seeing the O2 readings out of whack, that told me that I was confident that the readings didn't go what criteria we go for NCIs to pass and go.
Yeah.
So, and it stuck out like a sore thumb was the O2 readings.
Yep.
I actually reached out to Adam just to make sure, because this is now you got the insulating company that does building science a little bit with it. So
Yeah.
Adam, I've just from knowing him over several years now, seems like he's maybe a little more versed than your average HVAC contractor, and even sometimes the building science approach. He's like he's got some knowledge with that. So I called him before going on this call. Stuck out to him like a sore thumb was those two was the O2.
Yeah.
The O2 told me it was overfired. That's what it told me. Overfired. And we take any combustion call serious, let alone this one here. The gentleman, once he knew we were on it, and I called the homeowner, scheduled with her, and you can see the worry, hear the worry through the phone with her too. Furnace, it was 85 degrees, so fortunately furnace wasn't on. She didn't need it at all, but we it just felt like we knew we had this. We're going to figure this out. There's no question. And if I got stuck, I'll call Adam or one of you guys at NCI. So because you guys are so great answering the phone too. You guys are like, we have like, I don't know, I have Casey's number here. I have probably like 6-7 instructors.
Oh yeah. I was just on one before we even started this, and the guy's like, I got a common vented water heater, 80% furnace that's sidewall vented. What do I do? I'm like, run. 2-story house, can't run vertically or anything. Yeah. I'm like, just run. Don't, But that's cool.
Yes.
That's
so
awesome.
It's something about just being that confident, and it's not being cocky either. It's just being confident, knowing the knowledge that we gained and from our classes, our training, anyone would have gone to NCI's classes, like just the first year, like going out, you would have figured out this problem staring just jumping off the page. It's almost like the worksheets they give you in class where they're giving you and this was easy. It just jumped out just to me. And then so you felt confident knowing going in that you were armed with some knowledge, so, yeah, just felt good to know that you're going to get this figured out for the client, which is the homeowner, and the other company that does insulating, trust you that they brought you in to this mix, and
Yeah.
we're going to get this figured out. So that was kind of nice.
Now, so you go out to the job. Well, it's 85 degrees, summertime. I did kind of see in the little report that you put together that he was detecting 3 parts per million ambient of CO in the space. Were you picking up anything when you started doing when you were doing any testing?
Well, I did the testing. I did not pick up anything. They had turned off. They had locked out the furnace, and here was locking out because they're not the insulating company is not an HVAC company, so they're locking out as they have to have it off. They don't
Gotcha.
they don't mess with any wiring or anything like that.
Yeah.
They called me immediately and let the homeowner know, let me know it's off. They turned the water heater off too. And so when I got there, my ambient CO, I had my sensor con with me, personal CO monitor.
Yeah, these little guys.
Yep. That little guy. Yep.
I mean, I'm a little bit crazy with it. Here's another one. I mean, I got them surrounding me everywhere I go. So,
hey, when you've gone to NCI stuff, you understand why you do. I know. Yeah, I have a couple clients now that carry portable ones when they go traveling, when they go to vacations, this and that. They carry them. So
they should.
Yep. Yeah. So I had that on me, and then I brought my Sauerman. I forgot what model it is. My Sauerman combustion analyzer with me, but I turned on my analyzer outside, but I still have my personal one on me, and they both reading. Once the ambient CO was reading 0 in the space, which wasn't surprising because the furnace was off completely and the water heater was disabled, turned off.
Oh, okay, all right. Even though, I mean, I think it was the other guy's report. It must have been from when he was testing it. 3 parts per million. It's not a whole lot. It is not life-threatening at that level, but over time, that's the biggest thing. If you've got some sort of unit producing even just a small amount of CO, and you're exposed to that over a long period of time, all it takes is 3 parts per million to start affecting our health. It could be the long term. It could affect children more. They can start developing asthma at a higher rate. So any level to me in the house is you don't do it. You don't want it in there whatsoever. I don't know if you take the same approach.
And what would be your cutoff? Yeah, what would you? I mean, we have that now in our checklist. Ambient COs on our checklist for maintenance, no matter what. We have that just so we know. We measure that, not just the combustion of the appliance, but what. So your target would be 0. Obviously, is ideal, but I guess even 3 would be too much for you. You have to find out why.
Yeah, I'm just like I said. I'm a little crazy. Yeah. If they're cooking, okay, let's bring the V back into HVAC. Educate them on that type of stuff. I still want to know where the heck it's coming from. Because that 3, it may be 3 now, but it can hit hundreds later. So kind of cross my T's and dot my I's type of deal. Where the heck did it come from?
And most people don't have the combustion analyzers like we do, right? And the data loggers, the monitors like we do. So, how would you monitor that and know that it's fluctuating? Unless you're one of the NCI geeks like us.
Yeah, we may go down rabbit trails from time to time.
Yeah. Yep.
So you measured it, you found it where it was at. Um, you say it's over, or you said it was overfired. So how did you fix that overfired situation on that unit?
Yeah, and that's what was jumping out the page was overfire. Yep. So jumping out the page, the screenshots of the testo analyzer, combustion analyzer. That's what was jumping off the page. I'm like, let's. But what I started was I had my sensor con on me. Walked in, CO, ambient CO, 0 parts per million. Didn't start the furnace yet. I'm just getting my test gear out. So had my Sauerman combustion analyzer out, getting it prepped, getting my manometer out, just getting my little tools and stuff ready to when I turn the furnace on. But I took basically looked at the data plate, verified that the orifices were factory orifice size of 43, verified that visually. That was on a data plate and then on the orifices themselves. So the furnace was not started up at that time yet. Data plate also said the manifold range was 3.2 to 3.6. Gas inlet 4.5. So just looking at the data, just to kind of profile the furnace. You know, it's a non-condensing furnace. It's 80%, so non-condensing. Profiling it. Upflow. Oh, sorry, this one was a downflow. Sorry, downflow. So once I kind of just profiled the equipment, then I started the combustion analysis. Well, turned on the furnace, the combustion analysis. My manometer was ready on the manifold side of the gas valve. So when I turned the furnace on, I was reading manifold pressure of what gas pressure was going to the manifold for the burners. As I turned that on, the combustion analyzer was already reading, and the probe was ready checking the light off on the furnace. So seeing the light off sequence on startup with the combustion analyzer, and on startup, the combustion analyzer was at 234 parts per million, and that was a pass for that. So they didn't say there was an issue with ignition, but that's one of the
So
things we learned with
I'm gonna
NCI.
I'm gonna interrupt you real quick. I'm sorry. I don't know if Casey lost internet connection. He just fell out for a second.
Yep.
But for people that haven't gone through NCI training, can you do your best to describe why? I know that's kind of like it's a weird thing for people, right? And a lot of people think you should never test for light off. Um, why is that valuable? Why does that number even matter?
Yeah. So light off, as we learned with Jim Davis's training and studies and findings. Light off, depending on the characteristic of the furnace, even goes for boilers. Um, that lets you know how safe appliances lighting, whether it's a condensing furnace, non-condensing, or a boiler, whether you're possibly too much gas or not enough gas, for light off, because that can be delayed ignition. I've seen some that the part of it's already too much gas going through too quickly, and then you have late light off as well. Sometimes it's too slow, but that light off pass go lets you know that the burners are igniting properly and safely. So then you can eliminate any questionability or any, you're not guessing if that furnace boiler is lighting off safely.
Yeah. So we look at we're monitoring specifically the carbon monoxide reading
Yes,
during light off.
sorry. Yes, carbon monoxide. Yeah, sorry. Yep. Carbon monoxide is what we're monitoring on that one. Yep. We're targeting that. Yep. Focused, hone in on there at startup, at light off, and then record that number. That's what we do. But yeah, so we're honing on that, and depending on what type of appliance it is, tells us what range is safe, acceptable.
Awesome.
From there, as it stabilized, uh, So yeah, so I was trained to not. I'll back up. Yeah, was even from the company out in Colorado that was teaching me a little bit about combustion. Never put the probe in the flue pipe until it lights off. Wait a few minutes, and then. But from NCI's practices and training, the right thing to do is monitor light off, and so we've it's pretty eye opening when you start doing that too. Just the light off part of it. Um, from there, once it lit off, I was waiting for my combustion analyzer just to stabilize. So it takes a few minutes for it to stabilize. I was noticing the actual manifold pressure was at 4.49, so almost 4.5.
That's crazy.
Yes, and if you remember, this is what I think happened. If you remember, our gas inlet minimum. This is for the gas inlet minimum, not the manifold side, but the inlet gas pressure minimum was 4.5. The max was 13.6, and I was measuring 4.49. That is not the that was the manifold pressure, and gas inlet minimum was 4.5. So that tells
Ooh.
me right there that when we jumped from the just a little bit, because we initially got the call, well, the initial visit out was 1,839 parts per million, and the visit June 2nd. The HVAC company came back out, did some adjustment to make it safer, supposedly, without a combustion analyzer because they're too expensive. And then I see the 4.49. So that 5,309, I mean, it went up more than double. So I'm thinking they read that wrong. They're reading off the data plate and thinking the inlet gas pressure of 4.5 was the minimum and adjusted the manifold to 4.49.
Simple mistake, but the biggest thing that we can't stress enough is, I mean, any of you listening to this out there, do not adjust gas pressure unless you have a combustion analyzer in the flue. You are taking a huge risk there. That is the only one and true way to tune in a piece of equipment, because when you get to that point, it may say 3.5 on the valve, but you don't know if 3.5 is too much without having that combustion analyzer. You have to have that thing put in place before you adjust anything.
And to your point of that is when I seen that 4.49, I did not make any adjustments, and I was looking at my analyzer because it started stabilizing. Well, sorry, it did not stabilize. So it was,
Yeah.
I didn't want to. I already knew it was going to climb to 5,309 and higher, potentially
Yeah.
higher, right? So at that point, even though I seen the 4.49, so I just wanted to see light off and what the then I start looking at my analyzer because it's enough for it. Now we got the light off. Basically, it ran long enough. Light off is off of there now. So now we're going into the run cycle. And so I start backing that manifold down. I think initially start backing it down to 3.5, but I'm still letting my combustion analyzer settle out because now it has to adjust to my new my new manifold pressure, and it's got to level out and normalize.
Mm-hmm.
So I took it down closer to 3.5. Readings were looking good. Let's see here. So as it settled out some more, I let it run for 20 minutes at least. I mean, this cycle was 20 minutes. This cycle.
Yeah.
I was happy with the. Let's see here. I was happy with seeing that the oxygen. Well, first of all, the CO. That's what I targeted on here. I wanted to see the CO was going to be my target is less than 100 parts per million for a pass. So my combustion analyzer, my Sauerman one, yep, I was targeting the CO when I was starting to calibrate this down. to find the sweet spot. As I was calibrating it down to 3.5 and lower, I think I settled out at, let's see here, what the actual gas pressure I settled out at the very end. Let's see here. My gas pressure I tuned this down to was 3.25.
Okay.
But I didn't just go by gas pressure. To your point, I did not. I'm going by NCI's practice of our guidelines and parameters to properly tune and calibrate a combustion appliance. So once that falling to that spot of 3.2 inches was guided by the CO. The CO was now 47 parts per million, well below 100. Our oxygen was in the proper guideline now of 8.0, which is would be a pass for NCI standards.
Yeah, 6.9 is where you're looking for.
Yes.
So.
Yep. And so I the first one we focused on was CO, and then the oxygen kind of told us was because the CO is for safety, and the oxygen is more for efficiency. And that's what told that just this verified then the combustion analysis with the recalibration, it was overfired.
So let me reframe what you just said, Vince. When you're going through a process like this, you always prioritize safety first. That's number one. You're trying to dial in and tune the furnace or boiler to safe operating conditions, and then you look at efficiency. You're trying to get it safe before anything, right?
Correct. Exactly. Yep. That's what we've been trained with NCI. Yep. Safety number one, paramount, which makes sense, and then you go for efficiency. Yep.
Awesome.
Yeah. Every time. Now you mentioned you were measuring for 20 minutes.
And just on this cycle. Yep.
And why I know why, but why are you measuring for so long? What are you trying to see within that time period?
So I'm trying to see if there's a pattern where it's going to climb or fall or just keep diving the numbers or the trend. I'm trending it. And some of the readings, as it stabilized, and I basically, after I calibrated it to what I thought was a good, safe guideline, I'm just not going to, all right, it's safe at 47 parts per million. I need to see if anything's going to change as it runs 5 minutes, 10 minutes in. As the front door is closed, I closed and opened doors. This was in the kitchen, like a mech room in the kitchen. It had a door that was partitioned. So I wanted to see if anything in the house could cause an impact too, as I open and close doors on our reading. Being, the return, I believe the house was at, we have a micromanometer, TEC micromanometer. We've just been learning more with that as of a year. We're not experts with it, but been learning more with it. And I believe I may be saying this wrong, but a dynamic building pressure was at, with the furnace running, was at plus 0.03 pascals. So we didn't see anything crazy happening with the building pressure. And I'm sure the insulating company would have tested that again to make sure that we didn't miss anything on that. But so basically just making sure that this is not, the CO isn't climbing, and we start seeing the trend, and we start seeing was the oxygen. Actually, let's see here. The oxygen was I'll start with the oxygen. The oxygen was at 8.06. A couple minutes later, 8.17. A minute later, 8.09. So, and then the fourth reading, let's say it's a couple minutes later, 8.06. That's called a trend. And it's not climbing or falling. It's kind of staying in a I forgot to call it, maybe a little roller coaster, maybe call it, but it's staying
Yeah.
it's trending in the right pattern that we want. The CO, I wanted, obviously that's the safety one. That was at 5,309 when we were called out there for the second called out there because that was the reading that it was found of its last reading from the building from the insulating company. So after we thought this was plenty safe, trend on that was 49, 46, 48, 47. Not climbing, not falling.
Yeah. Yeah, we call that. I don't know if Jim dubbed that one or not, but we call it a roller coaster curve.
So I did. Okay. Okay.
Yeah.
And it's a good roller coaster.
Yeah. There can be bad roller coasters. So.
Yeah. Yep. And then so that's hopefully I answered. Yeah, but that's part we want it to make sure it's not like, okay, we got a good reading screenshot, it's good. Let this thing run. Let it run. And that was just that cycle, 20 minutes. So we like, all right, we compared it to the next cycle. We probably let the furnace run about an hour total because we can't be messing around with safety. We're the experts. We're called in. We're gonna, if we say it's safe with our training, it's safe. And I'm only confident because of training, the NCI training. That's the confidence where it comes from.
Oh, it's not just that. That gives you the starting point. Confidence is actually, really comes down to you putting it into practice. You taking that initial step and being like, you know what? I'm going to see if these guys are really crazy like I think they are right now, or maybe they may be right. Right? I mean, first time I met Jim, I'm like, dude, this guy is nuts. And then I started testing and I'm like, you know what? I don't think he's as crazy as I initially thought.
Yeah. You're right on that too, because once you put it into practice, yes. I remember to this day still from the Des Moines class, August of 2019, first time I went to combustion class, NCI. Was excited to get this stuff rolling, and I knew I'd have questions and it wouldn't be the easiest, but just with the instructor and everything, where, hey, call if you have any questions. But the first time I did maintenance on my aunt's furnace in October of that year, there's called, if you've been to any NCI classes, it's called the DAM problem. DAM.
Yeah, whoa, this is a family show, bud. Family show, man. What does that mean?
That's for I'm used to just being called, I guess, the DAM problem. But I'll let you explain it more, I guess, if you want to.
It's just an acronym. Is all it comes down to. There's a set of readings that can show up that could be caused by multiple problems, and we call them DAM problems. And the acronym, it's dirt, alignment, or mechanical problems that can cause your CO to be at a certain reading.
I'll keep this story short. I remember, just doing maintenance on my aunt's home, and I knew from going to the NCI class how important this combustion analysis was. Well, the new training that I didn't just invest in the NCI training just to kick it around and we'll get to it when we can. Mm-hmm. I was excited. Like, this is what we're doing on every maintenance call, service call. So it's ingrained in us. Doing maintenance out there at my aunt's, and then I seen this CO was at 120 parts per million, steady, 120. Not bad, a little bit over our 100, a little over 100, but wasn't deadly or anything, wasn't anything a red flag. And I told my aunt, I'm like, this is 120, it's, it's not dangerous or anything, but it should be below 100. I'm like, let me get back to you on this. And no later than a day later, I was driving, it clicked in my head what it was. Because it was 120 and stable. It did not, it stood there, just kind of glided there.
Yep.
I'm like, I didn't clean the burners good enough. The in-shop burners. I'm like, I need to pull the burners. This is a damn issue. Pulled the burners, cleaned them. I can't get out of there quick enough. I'm like, I know the problem now. I know it. Cleaned them. It went on down to somewhere in the 50s, CO to the 50s. And that's when it
Yep.
clicked. That was the first, this is my, like a month or two after the class. I'm like, wow, this stuff does work.
hmm
And that wasn't a safety issue. That was just like, okay, if just in your guys' just NCI's protocols, is if it's kind of at this pattern here, the CO, this is what it could be right here. Boom.
Yeah.
And that's what it was.
So,
Yep.
that's individual situation wasn't a safety issue at that time, but if that furnace was left untouched for a long period of time, it could have potentially gotten worse, right? So it could have turned into a safety issue.
hmm
And the other part of that, yes, and the other part of that, actually, I was able to disclose on the furnace because of NCI again training, was the flue temp on first stage was very cold, so it could cause rusting and could cause condensation. So
Yeah.
I would not have known what's the acceptable flue temp is because the first stage was under fired. It was at like 11. Oxygen was at 11 or something, 11 to 12, and
hmm
uh, tune that in. And I wouldn't want to tune that in for 9%, ideally around there, 6 to 9%. But anyways, I wouldn't want to tune that in if I had 120 parts per million ready. So I cleaned the burners and then I tuned that in because you do not want the CO to be going higher. If you're doing oxygen is for efficiency. If I had 120 for CO, I'm not going to be trying to tune the oxygen leaner and increase the CO.
Yeah, exactly.
But so that was eye opening to see the flue temp too. That was the first time I seen flue temp that was cold, and it could cause extra rusting of the flue pipe and the heat exchanger.
hmm Yeah, it's probably one of the most overlooked measurements that anybody doesn't pay attention to is your flue temp. I remember running around and customers would ask me, "Hey, what's that white powder on the flue? Why is there water streaks on there?" Oh, that's it's hitting humidity in your garage, or that's just normal stuff. You must have chemicals in the house that's rusting your flue out,
Yep,
and just walking away, right? And then I realized, oh my, how wrong I was.
I'm there with you. I did plenty too, and we mean well, right? But
hmm
we didn't know you're in your, and yeah, I mean, we were just ignorant of this information, and
Yeah.
yeah, just yeah, the even for flue temp for condensing furnace is key too. We've seen flue temps. You figure just for non-condensing furnaces, but we saw people's issues with flue temps for PVC that were way too high, 140 and higher flue temp on PVC. We go out there, static pressure, retro commission, and we're just doing blower speed change, static pressure, doing what NCI like protocols, standard stuff where you could probably learn to do your first year doing this stuff. And we see the flue temp drop to like 110, 105,
Yeah.
all on airflow going across the heat exchanger, because it's affecting residence time.
So your combustion testing led you to an airflow issue, which there in turn gave you an airflow renovation.
Yes. Yes.
Yeah.
Yep.
Dual purpose.
Oh yeah. 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 It's like you have answers for stuff that you never, like you said about the white powder, I think carbonic acid, on the flue pipes.
Yeah, carbonic
Yeah.
acid.
Yeah. That like I plenty where you didn't know what the answer. You wish you didn't know and I'm sure the igniter probably, the flame sensor probably too builds up quicker too. But I was taught too must be chemicals in the air. That's what I was taught too. I'm like, oh, the laundry detergent you're using, this or that, and
Yeah.
but yeah, just having these answers is and then you start figuring out more. You start connecting the puzzle pieces together.
Mhm.
And
Now you got your run test. Everything looks good. Everything's under 100, stable. Oxygen's 6 to 9%. You finished off there, and you had a good flue temp too. you didn't just stop with what we call the run cycle. You also finished with shutdown. Why did you take measurements at shutdown, or uh, maybe explain what shutdown really is and why you take those measurements at the end?
Yeah, just insight that NCI again, Jim Davis's training and um, you know practices over the years, his knowledge that he's gained over the years. This shutdown process, never heard of it till NCI. um, that CO parts per million. Uh, how we see that pattern of CO at the shutdown process can tell us if potentially the gas valve is leaking by gas. So how that trends can tell you if the gas valve is actually leaking, which is pretty amazing from trending a CO parts per million count.
Yeah.
That's kind of
So
sorry. Go ahead.
no. Keep on going.
That's just kind of that's the last part of us making sure that the occupants of the home are safe. They relied on us for our expertise, and part of the last part of your diagnostic, and you're kind of like, okay, the system's good to go. You can walk away knowing that you did your part. It's safe. If it was for your family, this is we do what we do for our family. We do for clients. There's no test that we don't do for our family that we don't do for our clients. Everyone's
Yep.
home. You let us in. We're treating you like you're our family. With our, thing is data. We use our data. Data is everything to prove that.
Absolutely. Prove through. I mean, everything that we do has to do with math or science. And in order to achieve those or figure out what's going on, you need numbers to figure that stuff out.
And that's exactly what helped the company that called us out. They were going by numbers, the blower door test and all that. And the just I got to meet the homeowner when we did our testing. We finished up everything. We finished up. I was buttoning up. Um, her her daughter and her son were home from college. It was during the summer, and they let me know how worried they were when they were so thankful. The kids were the young adults when I got done with my testing. They just were.
I bet.
I even left my carbon monoxide monitor behind for 2 weeks to make sure when the renovations were done or getting done or in between that if they see one particle parts per million on that CO monitor, call us. I left
Yeah.
it for 2 weeks. Not one, not no alarms, no nothing. But it's a monitor. It wasn't a CO
Yeah.
monitor I left behind. We have a loaner one we give to our clients once in a while, and that just helped to
Nice.
validate that we did it right and that we the safety level on this is really high. But very appreciative. The kids were bumped into the mom, and she was the worry off of them just dropped totally because they
I
thought
bet.
they were in for some trouble, like a lot of money to fix this. It was not. You didn't have to get a loan to fix this.
Yep.
It cost some money. We charge accordingly, but it didn't cost that much at all compared to what another maybe company would have done possibly. Um, she said, "How come they don't have the instrument your company has?"
Uh-oh.
And I couldn't answer that. Like I'm like I'm like you're definitely 100% right. There's no excuse. She couldn't believe how they could operate without that device, the combustion analyzer.
Mhm.
Um, yeah, so she was thrilled, happy. Uh, they were let's see, last part on this with this call here was let's see, the inducer motor had been replaced 3 times on this furnace.
Mm.
So I think it was overfired from probably the beginning a little bit or something with combustion, obviously. And looks like, when they tuned, but 3 inducer motors. I don't think that's normal for a 2011 furnace for 14 years old.
I think I've only swapped out 3 inducers in my entire career, let alone 3 on one system.
Isn't that crazy? Like,
That is crazy.
why don't you figure, hey, 3? We're going on 3 now. Can we?
Yeah.
It's like, I'm assuming combustion's probably been off a little bit on this. Initially, the initial test was 1,839, so it tells you right there it's been off. That was the initial test.
Yeah.
So
Did you you never got to see the condition of any of the inducers?
no, I did not. No,
See
this
what
is
they
off
look
the
like?
tag that was on the furnace. The tag.
Yeah.
Yep. So I seen the tag that was, but yeah, the HVAC company provided full services of all kinds of stuff. She couldn't believe they provide full service for all this stuff. She's on the maintenance plan, and they don't have this. Why don't they use this instrument?
Yeah.
And I didn't have any good answers for her with that. She was definitely
You don't know what you don't know, right?
yeah.
I mean,
And
it takes a lot to do what we do, So
It felt good to resolve because I'm a technician at heart, and a lot of we're just being able to have a resolution and solving a problem. This problem is the screenshot of, like I said, of this combustion analyzer we got before the call this is a very approachable call for any even first year technician or someone getting to learn combustion analysis. You would figure this out first year, and probably within months, just jumping off the page just by doing it.
yeah, I wanted to mention something too. Like, anyone who's listening to this who hasn't gone through combustion and carbon monoxide training, these type of calls are not always this easy. Like, I think you really lucked out. You walked into a pretty simple one, and you had a contractor before you that really didn't understand what was going on, right?
Yes. Yep.
And then one other point I wanted to make was, we have been throwing out, or you guys, I've been trying to stay out of it because Casey's like the master, right? So this is his baby. But
no, Jim's the skipper. I'm like Gilligan, so
yeah,
that Jim. Yeah, Jim. There you go.
But I wanted to make a point that, we've been tossing out numbers back and forth throughout this entire podcast, right? We've been talking about oxygen. We've been talking about rising CO, falling, stable, this, that. I caution somebody who hasn't been to training, take any of this with a grain of salt, because all these type of diagnostics change based on what type of equipment you're working on. So this is a specific system and a specific situation, right? So you need to understand what you're working on before you start making adjustments.
Especially with
this would have to be my biggest recommendation for anyone that's watching this. If you've never attended a CO class, an NCI CO class, your next steps is to see when the next one is going to be available. And I'm not saying this to plug NCI. I've been to a lot of different combustion classes. And I'll leave it there. Don't try to attempt this stuff on your own. Okay. You can find NCI guys in your area. When you run into a situation like Vince did, right? He had someone, hey, I know he can do this, he can figure it out, and calls Vince out. For the time being, go that far if you're trying to take care of your customer. It'll go a long way. Find an expert in this stuff, because at the end of the day, this is a specialty, and you need to know the equipment styles, the numbers for each equipment styles. You have to have all this background information in order to achieve what Vince has been able to achieve with this customer.
And
I can't stress that enough.
To your point, we didn't start adjusting any combustion for my company until we got certified first before we start doing this. Before my company took any business, that's what we did. We got certified. Yep. Because I seen how deadly it could be. And then just even a new furnace, that that opened my eyes. Just seeing that was, just you better pay attention. And then you're calibrating something or not haphazardly and not knowing you're liable no matter what, yeah. So without the class, without the knowledge, you're not going to know where to start really, what numbers to look for and what guidelines to go by.
Exactly. I mean, I changed kind of my intro in class a couple of years ago, and it's like, in the most simplest form, what is a gas-fired appliance? Oh, it's a heating unit. Oh, it produces BTUs. I'm like, no, it's a bomb. You got oxygen, fuel, and you got shrapnel. That's what we're dealing with. I mean, it's rare to see gas-fired equipment shoot through the roof, but it does happen.
And that's why you need controlled combustion, right?
Yeah, exactly.
That's the idea of it, right? So we don't get that. Yeah.
You got anything, Adam?
Yep. I think we covered it all.
Nice.
Well, scratch the surface anyway.
Yeah. I did think this one would be more of a challenge in a way. I'm glad it wasn't, but because I was ready for it to be, I figured there's something else going on with the building, this or that. But yeah, so when it jumped out the page, we verified. Oh, okay. So not yeah, definitely something approachable. But yeah, definitely you don't want to do this just thinking you can do it from hearing us.
Yeah. Well, Vince, I want to thank you for sharing your story here. This is a great one. I don't think maybe the customers don't even know how at risk they were.
Yeah.
And that contractor that just kind of ran away from this and told the customers that it was fine. I mean, you saved your customers along with saving that contractor in your area. So hopefully one or two guys may recall this job and be like, oh, okay, we need to do something about this. It is worth the expense of buying an analyzer.
Yes.
So thank you for sharing your story with everybody.
No problem.
And just bringing awareness to, something so important that we overlook all the time. So I appreciate you, and keep up the hard work, man.
Thank you very much. I appreciate it. And it's good to get back to a little bit just, with NCI's practices too, with, just where we're able to go to the next level. So it's kind of full circle moment too for us to give back. So it's just, yeah, it's been a great ride so far.
Awesome, man. Awesome. Great seeing you, brother. And hopefully, well, now that Adam's in the Chicago area, you probably won't see me out there too much anymore. But that's a good thing. Hey, I love being out in the desert, and Chicago in the winter is a little cold. So, that's the end of this ride, guys, on High Performance HVAC podcast. If you got any questions, ideas, or a puzzle that needs working out, send it to us. We can maybe create something for you. So out here, we measure it all from airflow to refrigerant and combustion, because in this trade, if you don't measure, you're just guessing. And if you guys want, hit subscribe, like, share, do whatever the little clicky buttons do on the bottom of your screen, guys, and we will see you on the next one. Thank you so much.